All right, so let's do another one of these where we're verifying the trig function on the screen. So our first thing we're going to need to do is to get to a common denominator here on the left-hand side. Oop. So we're going to wind up with our common denominator of sine x plus 1 and cosecant x plus 1, both in quantity, multiplied with each other. So in order to get to that common denominator, I multiply this one by the cosecant x plus 1. So we get cosecant x plus 1. And on the right fraction, we've multiplied by our sine of x plus 1. So we get sine of x plus 1. So then what we're going to need to do is we're going to need to combine like terms in our numerator, and we're going to want to multiply out this denominator. So when we do that, we're going to have 2 plus cosecant x plus sine of x. And in the denominator, we wind up with sine of x times cosecant of x. And if we think back to what cosecant is 1 over sine. So when we have something like sine of x times cosecant, which is 1 over sine, my sines actually cancel out. And so we're going to just have here a 1 for that sine of x times cosecant of x. Then we're going to have cosecant of x plus sine of x plus 1 times 1, which is 1. So remembering that sine and cosecant are inverse operations, we actually wind up over here with 2 plus cosecant of x plus sine of x over 2 plus cosecant of x plus sine of x. And if you notice, our numerator and our denominator are exactly the same. So the whole guys cancel out, and we're just left with 1, which is 100% exactly what we were supposed to get this to in the beginning. So we verified this. Next one is really, really similar. We're going to start with getting everything to a common denominator. So we're going to take this function here, we're going to try and get this to equal secant of x, which means I need to take all of this and make it into a common denominator. So our common denominator is going to be 1 plus the sine of x times cosine of x. So then our numerator is going to be cosine squared x plus sine of x times the denominator for my left one, 1 plus sine of x. So then we're going to do a little multiplying out on the top. I'm going to leave my denominator unmultiplied at this point. So we're going to have cosine squared x plus sine x plus sine squared x over my same denominator. And hopefully by now we're starting to spot it. As soon as we see both a sine squared and a cosine squared added together, we should think about that Pythagorean identity, because sine squared plus cosine squared equals 1. So what we have is 1 plus sine of x over 1 plus sine of x times cosine of x. And from here we can see the 1 plus sine x's cancel out, and we're just left with 1 over cosine of x, 1 over cosine x also being secant of x, which is exactly what we were trying to get to. So that one is verified. Let's do one more in this video. It looks a little bit grosser, but it's the same kind of thing. We want secant theta over cosecant theta. I've got tangent and cotangent. And so what I'm going to do is, with this secant and cosecant, they're kind of annoying when they're set up like that, because I know that secant is really 1, oops, wrong pen. Secant is really 1 over cosine. And I know cosecant is 1 over sine. So I have so many fractions within fractions, it's really, really confusing as to what's going on here. So what this is 1 over cosine theta times the inverse of my denominator, which is sine theta over 1. So we wind up with sine of theta over cosine theta. And since all these other pieces in my function are in tangent and cotangent, what I can do is I can just write this as tangent. So secant theta over cosecant theta is the same thing as tangent theta. So my first step was to simplify this piece, and that's what we did over here. So we now have tangent theta times tangent theta plus cotangent theta. And we can multiply this out to get tangent squared theta plus cotangent theta tangent theta. But again, that's another partnership that's an inverse of each other. We had this in the other one that we did together. So I'll do this part over to the right. Remember cotangent, that's cosine over sine. And and tangent is sine over cosine. So cotangent, tangent, everybody cancels out, and we're just left with 1. So what we have is tangent squared theta plus 1. And that's actually one of our trig identities. One of our Pythagorean identities is tangent squared theta plus 1 actually equals our secant squared theta. And that's what we had at the top, that we wanted this to equal secant squared theta.